As more and more COVID-19 variants come to light, the need for masks have rapidly increased throughout the pandemic. Due to the massive influx of patients affected and those around them, small businesses and public spaces have a difficult time mandating mask regulations. To combat this, we have created MaskPass, an AI-powered mask regulator to ensure that all patrons entering a location have their masks properly worn. When a patron approaches our system, our AI face mask detection software checks if a mask is properly worn. If so, the kiosk sends a signal to our automated door to allow the patron through. If the patron is not wearing a mask or is not wearing one properly, our system will not allow entry until the mask is properly worn. Alright, now let's take a look at how we built our system. Our infrastructure consists of 5 major components: the central AI server, the control panel, the live kiosk, the Arduino control bridge, and finally, our motorized door. First, let's see how the AI detection system works.
The AI system in this demonstration was trained using tens of thousands of masked faces. The training of the model is all about simplifying. This means getting rid of unnecessary data such as color. Color isn't all that important for recognizing animals such as cats or dogs. A similar concept applies here but for masks as well. As for recognition, it is split into 2 parts. We are first using computer vision library OpenCV in order to detect human faces within the camera frame, then passing that face over to our model for a prediction on their mask state.
Now, let's take a look at how we implemented the control panel.
To control the AI and Arduino servers, as well as the camera feed, we built the control panel UI using PyQt5 and QML that is able to connect the live kiosk, Cloud AI, and door magnet to each other. When main.py is executed, it will create an application window through PyQt5 that is connected to a QML file containing the layout and design of the control panel. Then, it will connect the buttons on the control panel to methods that will control the toggling of the various services and servers. Finally, when Start Video Service is clicked, it will open another application window displaying the live kiosk.
Third, let's see how the live kiosk is handled.
To have live video feeds be transferred between kiosk and AI server, we utilized 2 flash servers running in parallel. With this, we are able to transfer live video in real time between the 2 microservices, as well as sending control signals to indicate when and when not to open the door. To do this, we used the Motion JPEG or MJPG video streaming protocol. In addition, as you can see on Miro, we implemented a bidirectional REST protocol that allows the 2 services to communicate, allowing for a high degree of flexibility. This allows the kiosk to be placed virtually anywhere, as well as being able to run on any platform, such as a Raspberry Pi to a Linux desktop.
Next, let's see how we made our Arduino control bridge.
Here is a quick demonstration of the Arduino control bridge. In this container here, we have an Arduino Uno, which interacts with our GUI and receives an open or close door command. From there, it uses its NRF24L01 radio module to communicate with this Arduino and send it that open or close command. This Arduino then controls an NPN transistor switch, which regulates the current flow between the yellow and blue wires inside of this 3-pin wire. Then this VEX V5 brain interprets that open or closed current flow as a 1 or 0, which then corresponds to open or close the door. And currently I have this whole system set up in a demo mode, in which case this Arduino is sending out an alternating open-close door signal every 2 seconds. And as you can see, the brain is driving this wheel back and forward every 2 seconds.
Finally, let's take a look at how we made our mechanized door. The hardware portion of our project consisted of a chassis that carried 4 wheels. There were 2 pairs of wheels opposite to each other, and they essentially pinched a wood platform to avoid any slip. The driving wheels were then synchronized through a series of gears, and they served to move the door smoothly. Finally, there was also a radio added in order to allow the AI to communicate with the robot in order to determine when the door should be open and how quickly it should be opened. We believe that this project will both reduce contact with employees as well as ensure that everyone in the establishment are as COVID safe as possible. As dangerous COVID variants begin to surface, the need for masks may still remain at the forefront of COVID safety. Moving forward, you can count on MaskPass to keep you safe. We are not only proud of our accomplishment in such a short amount of time, but we also hope that it can make an impact or inspire future projects similar to this.